Professor Bethany here at the Kenai Community Library. It's so great to see you guys again, and it's good to get into some science with you today. We will be doing an experiment where we learn a little bit about polymers and also things like solvents. And we'll be doing this experiment with water, a dry erase marker, and either a bowl or a plate that's either ceramic or glass. So you want it to be able to be something that if you draw on it, you can erase it. And it's safe to put water on it. So don't do this unless you have your parents' permission, because you do not want to make your parents upset if you draw on a plate that you're not supposed to. And also make sure it's a dry erase marker, not a permanent marker, because those are harder to get off. A dry erase marker should be able to be erased just by wiping it with your hand afterwards. So it's not a magic trick, it's just really cool dry erase markers. If you need to test the plate beforehand, you can always do it on the bottom side of the plate, because the bottom side should work just the same as the top side, just to make sure if it does leave a mark, it won't be really visible. But again, make sure you have your parents' permission. All right, so what we do is we're going to be using this dry erase marker. I have this nice orange marker, but they come in all different colors. And when you do a dry erase marker at first, it's wet and it'll smear. So if you draw with your dry erase marker and then just immediately try to erase it away, you'll notice that it's still too wet to erase. So it'll actually smear. And the reason is dry erase markers, their ink starts off very liquidy. It's because it's a polymer. A polymer is like a long chain of molecules and atoms that are stuck together, and it's mixed in with alcohol as a solvent. A solvent is something that helps it become a liquid. Dry erase markers actually can't be dissolved with water because water is polar, and polymers typically are non-polar, so they're like an oil, so they'll usually float on top of water. But alcohol is a solvent, so it can actually dissolve them. So then, once the alcohol dries off of them, you can actually just erase them. Even the smidges and smears erase right off. That's because alcohol is volatile. That means it tends to turn into a gas really, really easy. So at first, in the marker, it's a liquid. See how it's a liquid? It can smear and smudge. But with just a little bit of time, that alcohol will dry, and then you can erase it. It has actually evaporated from the marker solution and leaving just the dry marker. And remember, the marker is an oil. So this is what we're going to do. We're going to experiment and see if we can make stuff that we draw come alive using some of the properties we know about oil and water. Let's test it out. All right, so what we're going to do is first I'm going to draw my stick man. You can do any shape you want, but it needs to be really simple and it all has to be connected. So I'm going to draw my little stick man with his little head. And sometimes it's easier to use a new marker for this just because older markers sometimes have breaks in them. So I've drawn my little stick figure and I got to let him dry. Remember that the polymer, which is non-polar, is actually dissolved in alcohol. Alcohol can react with water, so we have to make sure it dries completely before we add our water. When you add your water, I would make sure it's at least lukewarm to maybe a little bit warm to the touch. This is because if you do cold water, it takes a lot longer for the water to get underneath your drawing. All right, I think he's dry now, so I'm going to go ahead and pour my water on. And you can see right away my stick figure is trying to come up. Oop. I might have poured my water too fast. His head came off. And there we go. So then, a little bit of a shake, I can get the water to go all the way. I've just got one spot where the water, got it. So now my little stick figure is floating in the water. And he did maybe I didn't pour my water quite slow enough. So he is kind of like broken in pieces. But you can see how it all kind of tries to stick together and it floats on top. That's because that ink, that polymer, is like an oil and it's actually less dense than water. So it'll float on top of the water, just like most of the oil in your cabinet, like cooking oil will float on top of water. And so we can actually do some experiments with this if we wanted to. We can try and pick it up and feel what this marker feels like. This is just this oily residue that the marker leaves, the polymer. So we could actually pick it up and feel it between our fingers. You can feel it's kind of slick, kind of smooth. We can also blow on it to make it kind of dance, or try and push it to see if we can get them to move how we want. So it's a really fun experiment, and the only thing you have to do to try it over again is to wash a dish, which I'm sure your parents will be very happy to see you do. So if you want to try it again, either get a new dish or clean your old dish so it's completely dry and draw your new shape on the new dish. Let it dry and try again. And continue to experiment. Maybe you want to test out how different color markers work. Do certain colors hold together better? Are other colors faster at releasing from the confines of your plate? Test it out, find out, experiment, and be a scientist today. Talk to you next time. Take care, guys. Bye. I don't know if I keep doing it so fast. That's my problem. I'm like...